Welcome in the third section of our course. In this section, we'll be using high-performance collection to optimize memory and CPU. So let's see what we will learn throughout this section. So at the beginning, we'll be measuring performance of primitive arrays. Then we'll be using collections that were built on top of those primitive constructs. So we'll be using linked list and array list. We'll be comparing performance of sequential collections from JDK. Third video will be about validating iteration and write performance of collections, so we'll focus on adding some logic together with collections. Fourth video will be about immutable maps from better concurrency performance, so we will see how immutability can solve concurrency problems in very effective and performant way. Finally, we'll be doing performance testing of filtering stream API versus standard collections. And this is the first video in which we'll be measuring performance of primitive arrays. So we'll be writing benchmark for integer array, and then we'll be writing performance tests for integer array. So we'll be comparing performance of iterating over both of those types. So this is our benchmark. So we'll be focusing on microseconds, and we'll be measuring also average time. So we want to measure how much time the iteration over array is taking. So we will specify two parameters. First parameter is 1000, second is 20,000. But in the real world, you can make it higher, but we will do it smaller to make this performance test execute faster. And we will initialize int array in integer array. So those two things. So in the setup, because this is our state also, we are starting int array and integer array using length parameter. And we are creating new random and initializing int array and integer array with exactly the same value. So we are generating value, and then we are using that value for both arrays to have exactly the same data for both arrays. Because if you will create really high number and insert it to the int array, let's say, a small number to integer array, that may affect performance because accessing higher number could be more costly. So first benchmark is int array. We are using black hole because we need to consume element that we are getting from array. So we can see that we are getting int array, and we want to pass it to consume, because if you won't do it, JIT compiler will optimize that and could remove that code entirely, so we'll get some different and weird results. Second benchmark is similar, but we are using integer array here, but also we are iterating user using the specific index. Also we can use, of course, for loop for comprehension like integer I, and we could specify integer array, but the performance will be exactly the same, or maybe really small difference, because this specific for comprehension array is changed to this one by JIT compiler. So there is no difference for compiler and Java runtime environment for that. So let's start the test. So after a while we get the results. We can see that for int array we get two execution for parameter equal 1000 and 20,000. So we can see that for the small array the score is 2.5 microseconds per operation, and first of all integer array it is similar. So for very low datasets it is not important if you will use int array or integer array, but often in performance tests problems can be detected and caught when we get bigger dataset to analyze. We can see that for 20,000 the difference starts appearing, so we can see that there is 48 microseconds per operation for small int test. And for big integer wrapper type, it is 54 microseconds per operation. So this is 10% slower. So 20,000 elements is still very small array. So you can start this test for a really higher number, like for example 2 million on 20 million, and you will see that the difference is a lot bigger for bigger datasets. But here you can use int array instead of integer array if you don't need to have the capabilities that are around integer wrappers.